Hello there, and I'm Bryden Oliver. I'm going to be talking to you this month at the February user group about the lessons I've learned from my 42 years of writing code. So, first of all, a little bit about me. So, my name's Bryden Oliver. I'm a solution architect here at SSW. You can see my socials. I'm basically just on LinkedIn and GitHub. I started working with Azure in the first month of its launch. We started a project at the company I was working at, working with those early Azure services, which weren't very many. I've spent 20 years writing software to work with database performance, so I know an awful lot about databases and how they perform and what goes on inside them. I also know an awful lot about Azure at enormous scale, because as part of those database performance products, I was responsible for what at the time were the largest Azure functions and the largest Cosmos DB deployments in the world. And if you've got questions about performance or design for Azure Cosmos DB, come and have a chat. I love talking about Cosmos. It's a fun sort of intellectual challenge, working out how to change the way you're working to work well with Cosmos. So we're going to be talking about what I've learned. So I think just to start, I'll give you the three big things that I reckon are worth knowing and will help you progress in software. The first one is don't underestimate your users. They've got an amazing capacity to surprise you in all sorts of ways, and we'll see in a few of the stories I tell some examples of those. The second one is to, when you're doing something, understand the risks that are inherent in what you're doing. So, for instance, if you're changing something risky, enhance the testing. If you're doing something that really doesn't matter, maybe you don't need as much testing. So balance how you approach a problem based on the risks of it failing or succeeding. And the third one, and this is the one that I think I've done very well, is understanding the common patterns that we use throughout the industry. Like almost all of the software you'll interact with is just building on common patterns and rearranging them in different orders. And if you understand all those common patterns, you can build quite complicated architectures just by basically joining boxes and lines and knowing what they mean. Okay, but let's go back to the beginning. So, in the beginning, dinosaurs ruled the earth. And shortly after that, we arrive at 1981. So we're going to talk about 1981 through to about 2023. And that's the period where I've been coding. So what was happening in 1981? Well, this was the cover of Time magazine in 1981. So over that period, we've gone from that to the cover of Time magazine in 2023. It's almost the same cover. It's just aged a little bit. And that period where Charles was a young prince through to the point at which he took the throne covers the entire period of home computing. Like, home computing didn't exist prior to about 1980, 1981. And when you look at that period, so much has been changing that whole time. The whole time, it's really felt like it's in constant flux. But if you sit back and look back on what's gone on in that period, you go, actually, there's so much that's still the same. Like a bunch of the principles you learn very early in your career just don't disappear. And we'll see a bit of that as we go through some of the stuff. Okay, so 1981, and my father brings home the Sinclair ZX81. So this was a mighty beast of a computer. It was the first computer that you could actually, as a person, buy and, well, afford to buy. So it's got a huge 1 kilobyte of RAM and 8 kilobytes of ROM. So the 8 kilobytes of ROM had a basic interpreter on it for you so that you could do things with this computer. And it had a 3.5 megahertz Z80 CPU. So it wasn't the world's speediest, but it did okay. Now, here's the killer. It cost $75 at launch. So that's $400 today. That was the first computer in the world that was under $400, as in $400 at the time. So it had dropped the price by about a factor of 5 overnight. So it's, and if you think about that, that's kind of the price of an entry-level laptop today, $400. So suddenly, it's almost anyone who wanted to have a computer could kind of do it. It wasn't a very spectacular computer, but like you could have one and you could start experiencing this brand new revolution that seemed to be coming very slowly. So a few other things about this computer. It was pretty much text mode only, and the reason it was text mode only was that a full screen of text took 793 bytes. So you didn't have much left of your 1 kilobyte of RAM after you've done that. Another problem was that the basic code interpreter took about another 100 bytes. So there's not a lot left after you've got a screen of text and 100 bytes. You've got like 100 bytes left after that to put some code in. And that means you needed to be really efficient or reduce the amount of text on the screen. And there's a few things that this machine did to try and save RAM. So if you look at that keyboard, and it's probably a little hard to tell because it's a bit tiny, on some of the keys, there's like a 4x4 square where there's some of the bits are blacked in. That's how it did graphics mode. So every character on the screen could be used as a 2x2, 2 pixels by 2 pixels. So you got like a 800 byte, 800 pixel screen. So that's pretty impressive video resolution, I can tell you. The other thing there is that there's a bunch of basic keywords, but basic had keywords like go to and go sub, let, and all of these, that just typing out those keywords would consume an enormous amount of your RAM. So what they did is they tokenized it and just stored the token in a single byte. So every instruction was a single byte. And have a think about what we just heard Adam talking about, where he's talking about now to feed large language models, we're having to tokenize everything again. And it's kind of for the same reason. So that principle of tokenization, which really kind of wasn't that important for 30, maybe 40 years, is suddenly kind of important again now because we've got another use for it. So this is something you'll see in the software industry all the time, that principles and little things that will go out of usage or not be required for a long time, and then suddenly they'll reappear as the solution to a problem again. And they'll become super important for a while, and then they'll drop away again, and you probably won't have to think about them again. But it's super useful to know about some of these. Okay. So moving along, we can see a bit of we can discuss a little bit of how much computers of that era cost. So this is 1982, so it's a year on from the ZX81 being launched, and there's a couple of other computers that have come onto the market. We've got the VIC-20, which was kind of the first Commodore computer that you could buy, and it was about $300. So it's significantly more expensive than a ZX81, but it's up to the price of a mid to high range laptop these days. And then you've got the Apple II Plus, which is kind of at the level of a really high end workstation that you might buy these days. So, computers in those days, there's still not that much out of the parameters of what we pay for computing now. It's just a vast difference in what they could do. Now, to put this into a bit of perspective, we might have a look at fashion from that era. So this is me, aged 6, just as I'm about to start learning coding. And we'll see a fair few of these fashionable jumpers, because that was the fashion through the 80s, hand-knitted jumpers. And everyone's mums would make these hand-knitted jumpers. Another thing to point out is, I was clearly a ladies' man at age 6. That little girl next to me smiling with the flowers I've given her. So, things started as maybe I hoped they would progress. So, moving on to 1983, and technology's moved on a bit. So my father brought home a Sinclair ZX Spectrum, which was the next to the sort of cheapest computers you could buy. But you can probably guess from looking at the case for that, what the huge change here was. And yes, the change was colour. So the ZX81 and pretty much all the computers up till then were working in black and white because you just didn't have enough RAM to store the extra information for colour. But the Spectrum had gone to a maximum of 48 kilobytes of RAM, so you could actually, keep a full screen of graphics in RAM and, have plenty of change left. You also had a larger tokenized BASIC, so there were extra keywords added. And this was where I actually started to build things that were useful. So my father was quite into challenging his children to achieve things. So what he got me to do was write maths games for my 2 little sisters, and they would have to, solve maths problems. And if they solved enough, it would give them a password, and they'd go to Dad, and he would give them a reward, but he'd also give me a reward for having written the program that asked the question. So it was a win-win for everyone here, and it really incentivized me to start learning to get better at coding. So this is just a quick graph that sort of shows the growth in RAM, and that's only over a 2-year period. And as we'll see, things progress along pretty fast still, even at that. But there were a few problems when it came to operating these computers. So the big first problem was these budget computers, they didn't have disk drives because they were too expensive. That'd be cost twice the cost of the computer or something, or more. So what you would get is software would come on a cassette tape, and you'd get your cassette recorder and plug it into the computer and play the cassette tape. But the other thing you could do is you could go down to the newsagent and buy a computer magazine. And these were highly sought after by the sort of computer nerds like me. And you would go home, and if you look at that page there, that's the code for a program. And what it is those are all the hexadecimal digits. So you would go home and you would madly type in all the hex, which is all the compiled assembly language. So this is in machine code. And you would hope you got this right, because of course the thing would crash horribly if you got it wrong. And I reckon it was about a year in they discovered the idea of checksums and started putting checksums on the end of the line. So it would just make you retype the line if you got one wrong. And the key problem here was you get pretty excited by the time you finish this. And many was the time I got to the end and madly hit run. I've finished typing in this game or whatever it was, and then go, oh, I forgot to save it to the tape first. And this would be after an hour or 2 hours of typing hex digits in. So you would have to then negotiate keeping the computer on for days so that you didn't lose all that effort too easily. And yeah, we're moving on in the fashion. Sort of flannelette shirts are starting to become a little bit of a thing too. And they was becoming popular around Australia as well. But moving along, we come to 1984, and the IBM PC is starting to become sort of moderately widespread in the business sector. So many companies or research organisations had one. And, you know, the price had come down from, I think it was about $6,000 or $7,000 when they first came out. So they're down to about $1,500 by now. So they're getting kind of affordable. So my father's work had one of these and he brought it home to do some work. Now these babies had two 360 kilobyte floppies on them, so not a lot of storage, and a 5 megabyte hard disk drive. So not a lot of storage, but, you know, pretty good for the time. And to show that RAM graph again, as you can see, RAM's starting to ramp up fairly spectacularly. Anyway, 1984, fashion's moving along as well. And I reckon, when I saw this photo, I'm about 30 years ahead of Steve Jobs there. I've got the black skivvy. I've got his haircut from the 2000s. And the reason I thought of that was 1984 was the year the Macintosh was first launched to great fanfare at the Super Bowl. And the huge thing with the Macintosh was there was all this fanfare, and then it was a giant commercial. The first Macintosh was a giant commercial failure. And why was that? Well, it cost $4,000. So that's about $17,000 today. So you can sort of understand why that one didn't take off. So you could buy a reasonable new car for that, or you could buy a Macintosh, and at that point it couldn't do very much. And if you look at that, Steve Jobs had a couple of things through that period where he made that same mistake. He launched too early, like the technology was still too expensive for people to be able to buy it. And if you look at him through the 2000s and 2010s, what Apple did very, very, very well was identify the point at which the hardware had become just cheap enough that people were prepared to pay for it in large numbers, and he would launch a product at the point that transference occurred. Now, that was where he was masterful. So if you look at, say, the iPhone, Microsoft had phones that were not dissimilar at just before that, but they were too expensive, or they had resistive touch, which was terrible. It was awful to try and use a phone with resistive touch. And suddenly, they managed to get it. He launched it at exactly the point at which that technology became cheap enough. And the iPod was another one. So that's what Apple became very, very good at, was launching at exactly the right time in the technology cycle. Anyway, moving along. So, and this graph, I think, really shows why the Macintosh failed. Like even the IBM PC, which was arguably more capable than the Macintosh, was well under, certainly under half, almost a third the cost. So it was a very different sort of environment. And moving along into the mid-80s, there were a few things changing. GW Basic becomes Quick Basic. But for me, the actual biggest thing that happened was Lotus 123 launched, and that was the world's first spreadsheet. And the reason my father kept buying computers was he was a research scientist. He used to research road surfacing, so bitumen roads. And at age 10, he thought, well, I don't enjoy doing all the sort of grunt statistical analysis. Bryden might enjoy that. How about I set him to doing it? So I spent, most of my teenage years and late primary school years doing statistical research for my father's research projects. And oddly enough, those skills that I picked up there, being able to do data analysis, and I'll point out, it's the really simple data analysis that you learn in sort of year 11 and 12 statistics. This is the biggest takeaway from this period, is that statistics are immensely useful You use it while debugging, particularly if you're running web services and stuff. Typically, you'll be looking at transaction rates, things like response times, and you'll need to know things like medians, percentiles. It's all those sort of things, and being able to spot trends in graphs, they're still enormously useful to this day. Moving along, and Turbo Pascal became enormously popular as a teaching language, and really the reason it was popular was that it involved only one compilation pass. So what you would do is you would take the code, you would read it, and by the time you'd read it, you could compile it in order. Whereas languages like C, you had to go through the code once, then again, and extract more pieces each time because you knew more about stuff that was later in the code. So it took a lot more compute to compile a C program than a Pascal program, which is why it was great for teaching, because you wanted quick feedback to the student. So it became enormously popular. The Borland one then became a product named Delphi, which is still around to this day. It's very niche now, but it was quite popular in the late 80s, early 90s. Interestingly, there's a bunch of stuff from here that's kind of still in use. So the memory management that they built for Delphi ended up as the foundation for the .NET Memory Manager, and Microsoft invested in Borland to get hold of the engineers who had built bits of Delphi and then used them to build those first versions of .NET. And that garbage collected memory manager was actually spectacularly performant, the one that they built for .NET. So it was quite an impressive technical achievement. The other thing they had, and this is quite a good example, is it was the first language to include sensible event handlers, where it's just a reference to an object and then a pointer to a function. And they patented them, which is why when you look at C# and all of the other languages after that, whenever you want to do an event handler, it was always enormously much more complicated. It wasn't just a simple operation to define an event handler. That's sort of got a bit simpler in the last, it's probably 5 to 10 years since that patent expired, and more languages are starting to integrate the simpler version. And around this period, where fashion was changing a bit, so I'm looking at the normal sort of computer geek of that era, but my sister's looking like Molly Ringwald from Fast Times at Ridgemont High. And yeah, that really was the fashion for quite a while. All the girls were dressed like that for a little while, and they had that sort of sullen look. That was very much the thing. And my sister was very good at that look, especially if I was in the room. Anyway, around this period, there was a big change in the way you did coding, and that was someone invented an IDE. I'm not sure who it was. It was either Microsoft or Borland. It's very hard to tell which one got to market first. They were definitely building them in parallel. And this was a huge change because you actually had, an editor and all of those sorts of things built all together, and you could compile in line. You didn't have to edit the text file, close the editor, run the compiler, it would compile, and then you would run the output of that. So it was quite a convoluted process up until then, and it's kind of the process some people still do with command when they're running all the stuff through the command line. But this was the first point at which you didn't have to do that. So you got to start simplifying the way you interacted with development. And as you can see, hand-knitted jumpers was still a thing, even at the end of the 80s. In fact, this was the favourite one of my mother's that she ever made. I think it just looks a bit like interference patterns now that I see it as a photo. So she was super impressed with it, but I wasn't quite so much. But this was also the period that I got my first job, which was kind of lucky. I just sort of fell into this one. So I got a job based off having programming skills and having done some data analysis on roads. The road authorities, a few people knew that I'd done this because my father had gone and done speeches at events for them and mentioned that I'd done the data analysis. So I was approached to put together a system that walked through the process of designing a bitumen road. So you would enter what sort of stones you had available and what bitumen you had available, and it would tell you what proportions of all these and sort of this sort of thing you should mix, and it outputted all of the instructions for you. And the scary thing about this is that product named CMix is still used today. So I wrote that in 1989 thinking, this is a holiday project. I'll write it once and, people will use it for a few years and it'll be gone. But it's lasted 30 plus years. And up until recently, I'd done all the updates, and they were probably about 5 to 10 years apart. But recently, they've actually gone to the effort of putting it on a phone. So while you can actually go out to the place where you're writing the thing and do it there. But back in the early days, what used to happen is you would type in all the sizes of all the stones and everything, and you would do this in the afternoon, and you would set it running, and then you would come back in the morning and hope that you could go and make the mix that you were going to lay that day. So, you would come back and the information was there in the morning. Now, the reason you did that was that it took about 12 to 16 hours to actually calculate that on computers in that era. So this app now, which is running on a smartphone, runs that same process in about 6 seconds. So that's just an idea of just how much processing power has improved in that period. It's pretty astronomical when you think of it like that. But that's not the real thing to learn here. The real thing that was an accidental opportunity. I could have said, oh, no, I want to go and play or whatever, and, being a kid, and just run off. But I took that accidental opportunity, and it's built something, and I can still say it's in use today. So now moving along, we've got some more fashion. This is probably, in my view, the worst of the jumpers, but still handmade. And what else happened about this era? I headed off to university, and one of the best things I did there, and something I would encourage anyone to do, is spend some time teaching in whatever way you can do it, whether it's teaching other engineers in your workplace, teach other students, whatever it happens to be. Make sure you do that, because it teaches you a whole bunch of stuff yourself about how to explain things and simplify complicated things down, so that, and where I use that most these days is talking to people like product owners, testers, and even more so with some of the higher level executives in companies. If you can explain it at a level just instantly that they can understand and grasp, you're miles ahead. The other things you'll learn from doing it are teamwork and mentoring. And I found that this was great. The key thing you're learning here is, by doing this teaching, is how to tailor communication to your audience. And that's one of the, if you go and look at school sort of communication and things, this is the key thing they're trying to teach you, is how to communicate with your audience best. And I find that anyone who's done a bit of teaching of others or mentoring of others, typically they really improve in this area. And in software development, it's a critical thing to be able to talk to, the other people in the organization about the work you're doing and how it affects them. So being able to explain it. Now, around this time, I got to work on an ultra-modern PC. So this PC here was built in 1947. It was, in fact, Australia's first computer, and it had been gathering dust in a basement at a university for 15, 20 years by this stage. But someone realised that it was actually a magnificent historical artefact. And what they got the students to do from the electrical engineering and the computer science departments was rebuild this. And in doing that, we had to understand its physical architecture. So you started understanding how, processing actually worked. And through that, you understood a system's strengths and its limitations. So in this, I just built the punch card reader. So not a lot of the hardware, but enough that you got a feel for what's going on in this system. And it was very interesting to see how this thing ran, because there was a bunch of limitations to this system that you wouldn't expect. So it's all valve-based. So valves are notoriously unreliable. So this thing used to run at 1 kilohertz, so it could do 1,000 clock cycles per second. And the valves would last about 10 to 15 minutes. So typically you wouldn't get a lot of clock cycles before you had to power the machine down and fix a few valves. So you had to have all of your punch cards ready and get them into the machine, get it through, and you might get through 2 or 3 programs before you had to shut it down and fix some valves. So it was quite the process. I can't imagine how they actually worked like that in those days. Because even with that, we got sick and tired of the punch cards tearing. So we actually designed aluminium punch cards so that we adapted the reader so that we could read aluminium punch cards because we get tearing them. So, and even that was annoying enough, but having to stop every 15 minutes to change the valves must have been terrible. You had to work out which valve was blown, so it took quite a while to find. So you didn't get very much done with that computer very fast. But the key thing you got to learn about doing that was understanding the architecture. And it was important then. With cloud computing, I find that it's actually more important now than it was back in those days, because if you can understand how the cloud service that you're consuming actually works under the hood, you know kind of what the failure points are, how it'll behave. If you double the amount of data, will it add an extra computer or will it do this? You'd start understanding what that system actually does inside, and you can understand what its behavior will be. Because a lot of people, they'll go, I double the amount of transactions and the thing got really, really slow. And then it got faster again. Why was that? I don't understand. And, if you understand the architecture, you go, that scaled out. It added an extra node, so suddenly it could cope again. And you go, yeah, that makes sense. But that's a very simple example. There's an awful lot of examples like that where just knowing how the thing worked inside, you could understand why the behavior you were having problems with occurred and work around it because you understood. And as you can see, fashion's moved on a bit, and long hair's become a big thing by now. And you can also see, that computers have got a bit smaller than those big IBM PCs. So they're down to about the size of a desktop now. It's just you get less in the desktop. But around 99, 2000, I started working in a small startup. And we built a bunch of things. The main things were payroll time clocks, point of sale systems, and a bit of telesales. And for those of you who are old enough, that telesales was for a company named Danoz. So if you remember Danoz Direct, you can ping me later and we can have a laugh about that. But what I learned here was I'll talk about the time clocks. So we built these time clocks, and if you think about time clocks, what are the two key requirements of a time clock? Well, one is a payroll one. One is that it records that when an employee touches it to, clock on or clock off, that it remembers the time. The other one is that it knows the time accurately. So our system was great at the first requirement. Unfortunately, it was really, really, really bad at the second requirement. So it was so bad that we had to go back to the people we were buying the timing crystals, which are the same things you get in digital watches, and say, well, what can we do about this? This is terrible. And they go, well, you could buy the ones that they put in high-end watches, but that's going to cost you about $400 to $500 a unit. And that was our whole profit margin. And we really don't want to spend our entire profit margin just getting a clock to work. So we started thinking about stepped back and went, well, the standard way of handling that requirement is get a timing crystal. What else has regular beats on it? And we came to the conclusion that power signals would. And it turned out when we approached the power company that they guaranteed that it would be 50 hertz over a day. Even if they lost a cycle or gained a cycle, by the end of the day, they guaranteed it would have been the equivalent of 50 hertz for the day. So by the end of the day, the time would be perfectly accurate. And we switched over to just counting the number of pulses on the AC power supply, and suddenly our clocks were super accurate. In fact, way more accurate than anyone else's, just because we made that simple change. So the key thing we did there was we went and asked people for solutions, and then we went, nah, don't like the solutions. Let's figure out what the requirements were and then figure out other things that aren't the solutions we've seen that might hit them. And that's quite often what you have to do in software is stand back, go, the users come to me and told me I want a box here and, a couple of buttons here to do this. And you sit back and you go, well, no, you don't. You actually are trying to do some other completely different operation. And this is just what you've seen somewhere else. And it seemed kind of like a clever idea. But there's a much simpler way that the user could achieve the same thing. So always go back to the requirements. Make sure you get the user's requirements, like what are they, and understand what they want to do, not how they think they need to do it, because you can quite often simplify things for them without them realizing. So there was something else, and this is a big thing that I learned in that period. So point of sales or cash registers in this era looked a bit like this. The key thing here is that there was a full desktop PC under the counter. So being a startup, and there's only two of us, I was the support that morning, and this was pharmacy point of sale. So one morning I get a phone call very early in the morning from some frenzied pharmacy assistant going, I can't turn the cash register on. What are we going to do when I open? So I go, all right, let's troubleshoot this problem. Okay, is there a light on the screen? Yeah, the light on the screen. Okay, on the printer, the docket printer, is that on? Yeah, there's a light on that. Is the scanner got a light on? Yeah, that one's working too. Okay, so we're going well. Most of the components are at least on. So then move to the computer and say, can you look on the front of the computer if the light's on that? And she rustles around, comes back, no light's on there. And I go, well, I know the LEDs on the front of computers are pretty unreliable in those days because they keep blowing. I go, so all I was going to find out from that was that the computer was on, not that it was off. So how do I figure out if the computer's on? Can you go and stick your head under the desk and listen and see if you can hear the fan? So he goes off, does that. Yeah, I can hear the fan. So I go, no, okay. I'm out of simple solutions here. I'm going to have to come out. So I get myself out of bed because she's rung early enough that I was still in bed, being at sort of late teens or something. And I've got ready and I'm dragging myself into the car, grabbed a computer and all the hardware to try and fix this. So I've got all the spare hardware on board. And then I get a phone call and it's the pharmacist. He's got into work and he's gone, how did you not solve this problem? And I've gone, what? I went through all the standard things. And so I walked him through what I'd done. And he said, when I got to the point where I said, and I asked you to listen for the fan, he sort of collapsed in hysterics. And I'm, what? Why are you laughing at that? And he says, it's so hot here in the pharmacy assistants unplugged the computer and plugged in her fan. Oh. But I've quoted this regularly, and the key lesson you learn from that is don't underestimate your users, their capacity to misunderstand or come up with new ways of using your software. Like, it's not just doing what you think is silly things. There's all sorts of other ones. They'll come up with creative things like using your spreadsheet to do ASCII art with or something. Things you never expected and uses that you never expected of things. So be aware that they'll do that and, have it in mind that there will be uses you never expected. So fashion's moved on and I'm getting a bit more floral, and I've got the shark tooth around the neck, which became really trendy for a little while. And we're getting into the 2000s finally. And from 2000 to 2020, I worked for a company called Quest Software. And while I was at Quest Software, I used all those technical skills I'd built up, but I really only refined them a little bit. Most of what I learned while I was there was the soft skills to join it all together and, become better at talking to stakeholders, learning how to interact in support situations, how to work with customers, all of those sort of things. But some other things that allowed me to sort of move from a sort of developer to a senior developer was, at that period, I went and learnt all of the common patterns. So things like queuing patterns and database patterns and how you might store things, how you might process things, a whole lot of algorithms and all of that sort of stuff. So that I was able to compose all of those different things into different bits of software. And there was a whole lot of the new, what are now outdated patterns like the factory pattern, which isn't really in use. That was a super new and exciting pattern back then, but it's still useful from time to time today to know about that one. But these days, it's much more understanding the architecture patterns inside cloud computing is where I think it's worth knowing the patterns. Like, should I use a queuing mechanism here, or why would I use queuing? Should I use a NoSQL database, or should I use some sort of file storage or whatever? There's all these patterns out there, and most of the vendors have these great websites full of architectures where you can see those patterns, which are turned into building blocks, joined together, and you get a whole solution out of them. Okay. So what I worked on here while I was at Quest for a lot of the time was database performance monitoring, and this is what it looked like. But there were a bunch of odd things that went on. So one of them was we had a customer, and you're probably going to guess by the time we get to the end of this story who that customer might have been, So they had, and we were monitoring SQL Server at this point, these databases that were deployed on ships. So each ship had a database and it was communicating back by satellite to their operations room. And what they wanted to do was send back all the monitoring data to the operations room. And they'd been through a few monitoring bits of software, and the key problem was the latency was of the order of 30 to 60 seconds. Not typically in a network you see, 100 milliseconds or something. And everyone's software just timed out. So we sat down and went, well, okay, we might as well try and solve this for this customer, because we get timeouts in other situations. So if we can get it to the point where we can just handle, effectively the worst thing possible, then we'll be able to sell. So we sat down and we built that and got that working. And by understanding the strength of being able to do that, we were able to sell that product to an awful lot of companies where they had no choice. We were the only vendor that could do that. And we understood that strength and sort of marketed on it. And that's very powerful, is if you know what you're doing well and where your strengths lie, if you're able to articulate that, but even just knowing it yourself. So then going, well, I'm really good at, say, API development, and in my team I'm the best. I'll volunteer to take the API work and maybe teach another engineer that. And by doing that, if you understand your strengths and the rest of your team's strengths, your teams will be much more successful. Now, another thing I'll talk about, which was a competitor of Quest, which had around 30,000 monitoring customers, which was similar to Quest where I was working. And we both had automatic update systems, which were hosted on websites. And our test environments both had, so to use these ones, you would upload, we as the vendor would upload a new update onto it, and then it would download onto all these databases and execute. Now, the thing is, all of these databases were mission critical. They were sort of in very vulnerable situations. And what happened was SolarWinds happened to be a little bit careless with what they set the password for the storage for the updates, and state actor managed to replace their update with something that added a backdoor into all these systems. And this was actually quite recent, that break-in. That was about in 2019. So there were 18,000 companies and organisations breached, including multiple intrusions into the US federal government and Microsoft, and a large number of other organisations. And really, that I looked at that and went, "Ooh, like that could have been me, but for the fact that we had a password rolling policy." They had a very simple password on their story. We'd just been slightly more sensible and put a password up. So, and this is a critical lesson, is we'd understood the risks of what we were doing and gone, like, there's a risk that someone could replace stuff there. We'll be very careful about, how you can get information onto that. And interestingly, that break-in changed the way governments look at security. But if that had been, sit there and go, well, I could have been the one having to sit in front of US Congress and explain what I did wrong and how that allowed the US government to be compromised, because they had actual developers from SolarWinds up there explaining what went wrong. I think that would have been quite confronting an experience if you had to do that. So understand the risks of what you're doing. You make sure you take a bit more care on things where there is higher risk, either to you or to your clients. Like, make sure that you protect them. So it's now starting to look sort of normal and a little bit corporate. This was actually at my first speaking engagement at a conference, which is 12 years ago. And let's have a bit of a look at what's happened over that period where we've gone. So we've gone from 1 kilobyte of RAM. Notice this is a logarithmic scale because it doesn't look like it grows very much. So it's gone from 1 kilobyte of RAM to 10 gigabytes of RAM over, that's 40 years. So that's not very long for it to have multiplied by very nearly 100 million times. So you get 100 million more times more memory in a computer than you did then. It's not actually that as big a jump in CPU speed, but like CPUs over that period have dramatically improved. You've gone from 1 kilohertz up to 1 billion hertz, isn't it? Gigas billion, I think. So it has multiplied by about 1 billion. So it's spectacularly changed. Okay, so pretty much covered all I'm going to cover. So before we go any further, one of the things I really love, and this is another thing I hope that you can take away, is that I love feedback. I love being able to learn from what I get back from others. So I'd love you if you can give me a bit of feedback. So you can scan the QR code, or we'll catch up with us later, and let us know what you thought of the presentation. So I'll give you a few seconds, and then I'll just quickly recap the key points I think that are worth from here. Okay, so what have we learned? First, and I think this is the critical lesson, is never underestimate your users. The second one that I reckon is super important is understand the risks of what you're doing and be careful. Just plan based on risk. Third, understand the common patterns. And then we've got a few, not quite as important things, but they're certainly well worth learning. Always gather the requirements. Don't take the solutions. And understand the architecture you're working with. It's really good to tailor your communication to match the audience you're with, and that one will help you progress inside organisations. It's typically that's the one that if you're a junior engineer, the first engineer who learns that one is typically the first one to move up and start progressing up the career ladder. Statistics are coming really useful, particularly when debugging. And then the other one that I reckon is really useful is understand your strengths. Play to them, work on your weaknesses, and do the same with your team. Work on your team's weaknesses. If you are the strength to the rest of the team's weakness, help out in that area. And of course, seize accidental opportunities. And with all of our fashion advice through this is my son. Last time I did this, he was sitting in the front row. But I like to think that this proves that fashion sense isn't hereditary, because I reckon he looks pretty stylish there. Okay. Thank you all for your time.
Thanks, Bryden. That was an awesome talk. As a young guy, starting development journey, your advice is always invaluable. I've got a few questions from the audience. So the first one, sometimes a very challenging problem can be demotivating for juniors. Do you have any advice for them?
Well, what I like to look at if we've got a very hard problem is it's not whether you solve it or not. It's where I take a lot out of learning something from that problem. So even if it's not a rampaging success, as long as I've learned something out of it and try and find something to learn as part of that process. So even if I have to go and learn a new technology or learn a new skill, go and do that and make sure you get something out of the really challenging problem.
For sure. All right, the next question is, with those Macintosh prices, has anything really changed?
Well, they're getting cheaper these days.
Yeah. All right, so are there any trends or ways of doing things that you noticed used to be done but are making their way back, or anything you wish was trendy now?
I've noticed that there seems to be a trend towards, probably most of the 2010s, we didn't worry too much about performance and everything headed to the web very rapidly. And we're starting to trend back towards all of the tooling, the quality of tooling you used to have when it was on desktop, because you actually had very good tooling to be able to build applications up until about late 2010-ish, I think. And that's coming back now. Developers are demanding good tooling even for writing web applications, and it's starting to get quite good.
Cool. Another question. So what is your favorite era from a technology perspective? And additionally, what kind of fashion were you wearing at that point?
Ooh, what was my favorite era? Probably the 2005 to 2015, because there really was an awful lot of an explosion of different things going on. Like you had sudden influx of phones and becoming the primary compute device. Like there was so much change. Cloud was just getting started. A lot of stuff was moving to web. So there was an enormous amount of change going on through that period. And to answer the second question about fashion, I was probably much as you are now in that era. I'd sort of given up on trying to be fashionable and just accepted my fate.
All right. What's like the oldest computer you had, and how big was the disk?
So, well, the oldest computer I had was that old IBM PC, but at one point I managed to get hold of a hard disk from I think it was the 60s. So the platters from this hard disk were about this size, and each platter held 16 kilobytes of data. So I had that mounted on the wall because it was actually polished copper, so it was beautiful and was very reflective in sort of odd ways. So that was a brilliant house ornament for many years.
All right, one last question. Have you still got that bad jumper?
No, the bad jumper has gone. I'm sure I've got another one just as bad.
Well, if my fashion sense is as bad as you say it is, then maybe I should be wearing it. All right, with that, thank you, Bryden. I'm sure everyone appreciated it. With that, that's Luke and Bryden from SSW TV signing off.